Welcome back. Today we will be solving another LeetCode problem, which is valid parenthesis. The problem statement is you are given a string that combines only parentheses. Your mission is to determine if the arrangement of these parentheses is valid. In simpler terms, we are checking if every opening parenthesis has a corresponding closing parenthesis and if they are correctly nested. Okay. Next, we will discuss what will be our approach to solve this problem. We will utilize a stack, a fundamental data structure that operates on the LIFO principle. As we traverse through the string, every time we encounter an opening parenthesis, we will push it into the stack. When we stumble upon a closing parenthesis, we will check if it matches the most recent opening parenthesis on the stack. If it does, excellent. We continue. If not, or if we encounter a closing parenthesis when the stack is empty, the string is invalid. I will explain you in a more practical way. Okay, so let's go to our whiteboard and see what will be the our approach and how we can solve this problem. Okay, here I am. We will take a stack to store the values or the opening parenthesis, and we have a map. In the map, we will store the opening bracket as a key and the closing bracket as a value of that key, and similarly for all three brackets. Okay, let's consider an example. If we have a input string as this, first we will iterate on the string. Okay, next we will store the current value of the string at the current index. That will be for suppose it is at 0 index, it is as 1 index, it is at 2 index, and it is as 3 index. First, the for loop will give us the 0 index. So we will store the current index of a string in a variable. We will name that variable, for example, char. So we will store that variable in a char variable. Okay. So basically this means that we have stored this parenthesis, opening parenthesis in a character variable. Next, we will check if character is at the as a key in the map. You can see it exists as a key. So what we will do is we will push this into the stack and it would look like this. Okay. Next, we will check in the next iteration. We will have this one. Now we will check. In character variable, we will have s of I, which is 1 at this time, so that will be our this one. So in character, now we have this closing bracket. Next we will pop the last value from the stack and we will store in a variable such as named or you can say top variable. Okay, so it will basically contains the value that is that we have pushed onto the stack recently, and it will take that value and we will store that value in a top variable. It will help in further looking up in the maps or while removing the elements from the stack. Okay, so first we will get this value by a method remove element in Dart, or in Python there is pop method. In TypeScript there is also a pop method, so that is also done. Next we will check if the top variable or the top value, which in this case is this opening round parenthesis. Now we will check if it exists in a map as a value. So you can see it exists in a map as a value and we will get that value. As I have said that in the current iteration, the character has this closing bracket, and now we have also this value. We will compare if they are not equal. It means that the string is a valid, because you can see that we have a opening bracket also and a closing bracket also, so that completes our parenthesis, so it is a valid string. Okay, so if they do not matches, that is a valid parenthesis. If it matches, we will have a condition something like this, not equal to. So in this case, if this condition is true, the string is not a valid is not valid if this condition goes wrong or gives false. It means that we have the string that is valid. It is a bit difficult in explanation as I am also confused. So let's back, but I have tried my best to explain the code or the approach to you. By jumping back into the code, we will see how we can solve this by writing some code. I am back in the code section. As I have told you while explaining, we will first take a stack. Let's take a list of string that will act as a stack in our case. Okay, stack, and we will initialize it with nothing. Okay, next we will take a map that to look up for opening and closing brackets. Let's take a map of string type of key, and the value will also be type of string, and let's name it as a bracket map is equal to. Here we have to store those brackets that I have mentioned in while explaining. So first we will declare this bracket, round opening bracket, and its value will be closing round bracket. Okay, next I will declare this, and its value will be a closing square bracket. I forgot the pattern. Here is opening curly bracket, and the value will be its closing curly bracket. Okay, so our map is also declared. This stack will be responsible to track what is the opening bracket or what is the recently opened bracket, and this bracket map helps in to look up is the input that is coming in form of string is something from this. If it is nothing like brackets, it will we will exit from the function. That is a bit confusing, I guess. Okay, so now next I will iterate over the loop. For that purpose, I will declare a loop for int I is equal to 0, and this loop will run until the value of I is less than the length of string. Next, we will iterate or we will increment the value of I by 1 in every iteration. So for that, I will write I plus plus. Next, we will store the current index of the string in a variable. Let's call it a char variable. So it will be of type string char, and we will store the current index of the string in the char variable. Okay, so that's also done. Next, we have to check if the char exists as a key in our map. That basically means that if we are getting a close opening bracket, because if we have a opening bracket, then we also have a closing bracket that completes the a pattern. Because if the incoming string is a closing bracket, then it's not a complete pattern. I hope that is clear. So let's implement this. We will check if char dot no, sorry, we will check if bracket map, we will use a method to look into the map that dot provide us contains key, and this will look for the key that exists in the map. So what we have to pass, we have to pass char here. Okay, so if it does, okay, let's say if the pattern is, we can also consider an example. For example, if we are taking a variable this, our for loop or I variable is indicating this variable, we will look into the map that it exists as a key. If it exists as a key, we want to add that bracket inside the stack that will keep track of all the opening brackets. Next, we will stack dot add, or we will push into the stack onto the stack. Okay, I will add char. Next, we have to see what if the incoming bracket is not a opening bracket. What if it is a closing bracket? We also have to take care of that case. In that case, first we will check if the stack is empty. That this check will guarantee us that it is not a wrong pattern, and we are following a good pattern. For that, I will check if stack is empty. Is empty returns a value true or not, indicating that our stack is empty. In case of if stack is empty, it will return true. If the stack is not empty, it will return false. If the stack is empty, we want to return from the function. We will return false because it will indicate, or it will show that the string is not a valid pattern or not a valid string. Next, we have to check what if the incoming bracket of in the next iteration, what we have receiving is a closing bracket of an existing opening bracket. So here comes the main function of stack. We will first pop the value from the stack that we have recently pushed. In that way, we can match if the coming and popped uh, parentheses are following a pattern. For that, I will take a variable string top and I will pop from the stack dot, because we are using list as a stack, so I have to use a method that list provide us, and list provide us remove last. This method returns a value and that it have removed from the list. Okay, now we have the value. This if will check if the top exists in a map as a key, return the value of that key, of that specific key. Bracket map and top. This will basically look for the value that the list has just removed from the uh, list. Then it will go into the bracket map that we have declared over here. For example, if the incoming value is a closing round bracket, it will first pop that value that we have pushed this into the stack. It will pop this value and then it will go into the bracket map. And what is the value of this key? It is a closing round bracket. Okay, so in the current iteration, the I is at this variable. I is indicating this variable. We have already stored the current value of I inside a char variable. So next we will compare. If these are not equal, then the pattern is not valid. If they are equal, we will do not return anything, and the control and the program flow will continue. Okay, so let's check. If it is not equal to the char variable, then it is not a valid pattern, so we will return false. In short, here we have compared the current closing parenthesis, which is char, with its corresponding opening parenthesis stored in the top variable. If they don't match, the string is invalid and we will return false. Next, we will finally, after iterating through the entire string, if there are any remaining opening parentheses left in the stack, it indicates unmatched parentheses, so we will return false. If the stack is empty, it means all parentheses were matched correctly and we can return true. So after the for loop, we can just return the stack dot is empty. This will return true if the stack is empty, indicating that our parentheses are correctly matched. If there is something in stack, it means that there are parentheses that are not correctly matched. So in that case, it will return false. Let's try to run this code and see what happens. Okay, so we are having an error. Let's see what is the error. Okay, we haven't placed a comma over here. Let's try to run this code again. Okay, here we have again an error. Let's see. Okay, here I have written this before. We have to return after this. Okay, now let's try to run this code again. Okay, so our cases are accepted, case 1, case 2, and case 3. So we can finally submit this code. To summarize, we have implemented an algorithm in Dart to solve the valid parenthesis problem step by step. We have utilized a stack data structure and a mapping of opening to closing parenthesis to validate the string. Each line of code plays a crucial role in ensuring the correctness of the solution, and that concludes our detailed explanation of the Dart code for solving valid parenthesis problem. If you found this breakdown helpful, don't forget to like and subscribe to our channel for more programming content. Thank you for watching, and we will catch you in the next video.